Welcome to surveying course. So in the last lectures, that is, we have completed the unit 1, that is introduction to surveying. So here we have seen the importance of surveying, the main basic objective, and then in the last lectures we have even seen how actually the survey is conducted on a field. So we have seen that triangulation is the method, and our basic philosophy for surveying is basically from whole to parts. So from entire area, basically we divide the entire area into small parts, and then from each part again we do all these things, all these surveying measurements. So here, so we understand the main objective of surveying is basically to prepare the maps or the plan of a given region. Okay, so now, so to prepare those maps and plan, we have to go to field, right? There we have some control points. We have discussed what is control point means, the points or the location where we know the latitude, longitude, elevation, all these parameters we know. So exactly we can locate the point, right? That is, we call it control point. So first we go to field and we establish the control point, means that point already we know all the parameters. So once we know from that point with reference to this control point, basically we do our surveying, means using this triangulation philosophy, we progress our surveying from whole to parts. Gradually we do, and then we complete our survey. So in the field, basically we have to take so many measurements in the sense, once for example, this is our entire area where we have to do the surveying, and we have few control points. Maybe this point latitude longitude we know, even this point latitude longitude we know. Okay, so maybe these 2 points latitude longitude we know. So from there what do? We establish the we make these joining lines, right? This line we call it baseline, and these 2 points we call it control point 1, control point 2, right? So now with these references, now we have to establish next point, another point, maybe similar to triangle. So this point you have to choose such that it can be viewed from this control point as well as from this point, right? Because if there is any obstruction in the middle, if maybe for example here you have a hill, or here maybe you have a hill, so from this point you cannot directly see this point, right? So it is very difficult to make this straight line here, because you cannot find the length also, like using the tape or the chain. Basically we find it out the distance. So if we can't see directly, if there is any obstacle in the middle, then we can't see this point right from here. So in that case, this point is not at all visible. I mean, we can't take this point as the next control point. So we have to choose this control point such that where there is no obstacle. Okay, so that basically will do it. For example, here maybe this point may be visible from here as well as from here. Okay, so this is our next control point. So like that, we make multiple control points initially to this entire area or region. So now from there, basically we can locate it with the nearby objects. For example, here you have a small lake, right? Here you have a small lake. So to locate this small lake, basically from here we take what is the distance, what is the length here, how much angle it makes with this, right? All these parameters we take on a field, and after that only we can locate these physical objects on earth. So basic objective here is basically we have to go to field and we have to take all these measurements, right? Measurement means length, angles, all these things we have to take it. So in this lecture number 2 or lecture number 4, basically unit number 2, measurements and errors, we'll be discussing this measurements and errors, because measurement is key important parameter in surveying. So whenever we go to field, basically we take so many measurements. So if we make any errors in the measurement, and you can see this error will be cumulatively increasing. If you have some error in this distance measurement, again from this point, now if you take another measurement, that also will have, the measurement will be wrong, it will have some error. So that's why error is very much important to discuss in the survey, because error will keep on increasing in when you further do surveying. So measurements and errors is a very important topic in the surveying. So this lecture number 4 here, will be discussing the significant figures in the measurement. So let's get started about. So what do you mean by significant figure? So as I mentioned, the record of any measurement is done using the number that includes all the digits that are known reliably plus one digit that is uncertain. What is meaning? What is this meaning? For example, you can imagine this is a actual real site, means 100 kilometer by 100 kilometer area, you can imagine, and this point to this point you want to find it out measurement. What is the distance from this point to this distance? That we want to find it out. So using tape, okay, using tape, basically you can fix one end of the tape here and you can pull it down to another end, so you can find out how much meter or how much centimeter of total distance is. So in meter, maybe you may find the distance is maybe, for example, 10.0386 meter, right? It may not be exactly 10 meter, but always there will be some fraction will be there, right? So the here, if you see, always when you take the small error, small distances, there will be definitely error. If one person is measuring, one surveyor went to site and he measured from here to here, that is 10.0386. Another surveyor went and he also asked to measure the same distance. He measured with the tapes and he got 0.0388, for example, he get it meter. Another person if goes, so he may get 10.0381 meter. So always there will be error. Human error will be there, definitely. We can't avoid the human error. So every person, new person goes, always their values will be, there will be small change in the values, because always there will be small error, right? You can see even one mm distance change, or even 1/10 of error definitely will be there. So for that, final values also will be changing. Okay, so significant digit we call it, to up to which we have the reliable value, that we call it significant number. For example, here in this length, three surveyor went to site and three surveyor measured three different length. Okay, so all these three you can see 10.038, 10.038. So up to 38, it is constant, right? Everyone got 0.10.038. After that, one got 6, another got 8, another got 1, right? So up to 10.038 is the significant number. Okay, and the last number is basically the uncertain. Uncertain means there will be some error will be happening. Each person will have some different errors, right? So that last digit we call it uncertain, whereas this up to 38 is the significant figure of this measurement. So that's why it is very much important to see how errors are introduced in a measurement. So that's why when we do a surveying for the large area, okay, so in that case this error will sometimes accumulate it. So once you make an error mistake in this length, so now from here to, if you want to find out another point length, then again the error will increase, or maybe there will be more error. That's what, so error will simply accumulate and accumulate in the numbers, and ultimately at the end it will be big. So that is, it is very important for us to understand the human errors and the significant numbers up to figures up to which we can reliably say that this length is up to this definitely. So the reliable digit plus the one uncertain digit is known as the significant figure or the significant digit of the measurement. So basically the reliable digit, as I mentioned, is 10.038 is the reliable, and last digit is basically uncertain. So the reliable digit plus one uncertain digit, one uncertain, so last digit would be uncertain digit, is known as significant figure or the significant digit of the measurement. So this is very much important. So now the significant figures indicate the precision of any measurement. Thus, it depends on the least count of the measuring device. Okay. So now last the digit is actually, we call it precision, right? If you are using the tape which has millimeter, given millimeter scale, it is given. So then it will have the accuracies will be very high, right? It will be very high because millimeter scale you have. So even you can capture the millimeter point also, how much length in millimeter also. But if you are using a centimeter scale or a meter scale, then you may lose few numbers at the end, because in the centimeter scale or the meter scale the division will be large, right? So in that case, you in the last few digits, maybe you may miss some points, some digits. So that's why significant figure basically indicates the precision of any measurement. Like if the number is very long, means you have the more accuracy, more precision, basically more precision in the measurement. Thus it depends on the least count of the measuring device. So least count in millimeter scale, it will be millimeter, right? So 1 millimeter will be last millimeter digit will be different. So basically that is the least count of the measure, whatever the measuring device you are using, so that will be the least count which affects the last digit of the significant number. For example, if a distance is measured with scale having least count in millimeter, that's what I mentioned example, a length of 20.6 centimeter has three significant figures, right? So if you take this one and you are using a centimeter scale, right? Centimeter scale means if I draw it here, mm, so you have a scale something like that, and every centimeter is marked here. Okay, so this is just an example I am showing here. So every centimeter is marked here. So this is a centimeter scale. Maybe this is 0 to 5 to maybe 10, maybe 15, something like that. So this is a centimeter scale, right? So with this centimeter scale, you went to site, or you went to a field and you are measuring the distances. So here the least count will be how much? So in centimeter, right? 1 centimeter. So if you have any point at the middle, right, middle of these two line, then always will take either you may take depending on the location. If it is at the center, then you can take always the even number, which one is even number, or if it is close to one line, then you will take this line as a distance, right? So the precision here is actually in centimeter. So if you use a centimeter scale and you want to find it out a distance on a earth, then the length, if you got it 20.6 centimeter. So 20.6 centimeter means, so 20 will be definitely that we call it, a reliable number. That is here we discussed, right? So 20 will be reliable number, but this zero point 0.6 will be uncertain. So someone may get zero point 0.5, someone may get 0.7. So this is uncertain. So the significant number is how much will be reliable plus uncertain, one digit of uncertain. So this one, so 20, 20 and 6. So this number has three significant figures, right? That is 0, 2, 0 and 6, right? These three significant digits. The digit 2 and 0 are the certain, while zero point 0.6 or the 6 is basically the uncertain, as I mentioned. So 20.6 centimeter means the length is basically 20 centimeter plus minus 0.5 mm or 0.5 centimeter, right? 0.5 centimeter, there will be difference. As I mentioned, if you get the distance up to in this point, middle of this two bar, then you have to choose either this one or this one, right? So error will be plus minus up to in this range, 0.55 mm or 0.05 centimeter will be the error. Okay, so entire distance is how much? Entire distance is 10 centimeter, sorry, 1 centimeter. So the maximum error may come, so that is the thing. So this lies between 20.5 centimeter to 20.65 centimeter. So the actual, if different person measures with the centimeter scale, one may get in this range. Okay, so now you understand using the centimeter scale. Basically, one example here I have shown, so you can understand for 20.6 centimeter, if it is you get it, then it will have a three significant figure. Now the determination of significant figures. So how you can find it out the significant figures from the field measurement. So we will follow some rules and conventions, which is the standard practice to follow. So these are the few rules you have to remember while measuring the distance or angle, anything related to values. If you get it, that in that format you have to do it. So first rule is all non-zero digit in a number are significant. All non-zero digit means apart from zeros, if any number is there on a number, that number must be a significant number. For example, if you have a number such that, so if you are measuring some distance or maybe some angle you are measuring, that is the angle in degree, for example, or maybe in radian you have an angle such that. So here the significant, so this number or this number, if you see, if you convert, for example, this is in millimeter, for example, if you convert it into centimeter or meter, basically you are multiplying it this number with 10, or you are dividing it into 10, 100, like that it follows, right? So this number, if you have this number, this number, this number, this number, all will have the same number of significant figures, namely 216. So as I mentioned, all non-zero digits in a number are significant, means here non-zero number is which one? 216. So 216 will be the significant. So here also in this number also you have the significant digit 216, 216, 216, everywhere 216 is the significant figure. So that is our first rule. Second rule is all zeros between two non-zero digit are the significant, no matter where the decimal point is, if at all. Means, see here zeros are actually outside it before the number, no non-zero number. 216 is before that. Now if any zero is there in the middle also, like 2106, so in that case middle zero will be the significant, middle zero also will be the significant figure that was mentioned here. For example, if you have a number such that, right, 0.000206, right, here these four zeros are actually no, before the non-digit number, non-zero number. Whereas this zero, if you see, this is middle of two non-zero number, right? 2 and 6, in that middle you have the zeros. This zero is significant figure. Whereas these four zeros and this zero is also, not significant. So even here also in this figure also 206, right? This zero is significant. 20.6, this is significant. So 206 is in, so these zeros are basically lying between 2 and 6 is only the significant figure. Okay. Now the next rule, the first rule, two rule is over. Now third rule, if a number is less than 1, the zero on the right of the decimal point but to the left of the non-zero decimal point are not significant. Means here if you see this figure, so this number is less than 1, right? So the point, the zeros, no, zeros right to the decimal point, right to the decimal point means these zeros, but left to the first non-zero digit are not significant. Means up to this first four zero I am talking about. So these four zeros are actually not significant, as I mentioned earlier. So in this digit only 216 is significant. These four zeros are not significant. Okay. So similarly, if you take this number, then it has this, so this is zero, this zero is not significant. Similarly here, if you did this four zeros after decimal point before the two has no significance. Okay, so that is our third, one two three rule we have discussed. In the next, so in the last slide we have seen the three rules. Now the next rule for the significant figures are the terminal or the trailing zeros in a number without a decimal point are significant depending on the accuracy of the measurement. For example, you have this one 23.60, right, meter. So you have measured a distance which is 23.60 meter. So now this trailing zero is significant or not, it depends on the measurement, accuracy of the measurement. So whether you have used meter scale or you have used kilometer scale or you have used millimeter scale, so depending on the accuracy of the measurement, this trailing zero will be significant or not, it affects. Okay, so in this number, the terminal zero has no significance, right? If the accuracy of the measurement is 10 meter. So if the accuracy is 10 meter, then this zero is not significant. Then the number of the significant figure of this, then this will be 2, 3 and 6. So these three digit will be the significant figure. But if the accuracy measurement is 1 meter, means even 1 meter change also you can measure, right? You can show. Then the terminal zero will have the significant, right? Then in that case 2360 will be the significant number. Okay, because now we can measure up to 1 meter distance also we can measure it, right? So that's why if depending on the accuracy, so if you are using more accurate scale, or if the accuracy in the scale is more, then you have the more significant figures, whereas if the accuracy is less, then you have the less significant figures. So that is our rule number 4. Then we have the rule number 5. The digit 0 conventionally put on the left of the decimal for a number less than 1 is never significant. However, the zeros at the end of such number is significant in a measurement. For example, this is in the earlier examples, earlier rules, actually we have seen that this zero before before the decimal point, it is not important, right? Like this number 0.120 has three significant numbers. There is zero before the decimal point is not, so this zero is not significant, whereas this zero will be significant. So all these things basically depends on the accuracy of scale and how we are interpreting the values. The number of or the trailing zeros in a number with a decimal point are significant. For example, you have measured a length 23.60 meter. So in that case, this last zero may be significant, right? Because last zero may be uncertain. So you have 23.6 is the certain, or the
that is the reliable digit, whereas the last digit may be changing, right? Some person may enter 23.61, some may get 23.62. So last digit is the uncertain digit. So total significant number, maybe it has 4, like 23 2360, all 4 are maybe significant. So these are the rules, for 7 rules, 6 rules basically we have discussed, for the significant number reported. So whenever you go to site, you have to measure the length, right? Length or angle, whatever we will take the measurement, that we have to record it in a paper. So in that paper, so how much digit will record, so which one will be reliable, which digit will be unreliable. So these are very much important for the survey. So that's why we are studying all these, in general conventions and rules in details. So some note point, you can see there can be some confusion regarding the trailing zeros, as I mentioned. Suppose the length is 4.7000 meter, right? It is evident that the zero has no mean to convey the precision of the measurement. So this 00, why did you keep 000? That means the scale you are using in that precision is very high. So that's why to denote that this is more precise value, like up to 4 digit we have significant number. So that maybe it can be defined. Therefore, these all 4 are actually significant. So 4700, all 4 may be significant, because we are showing the accuracy of the measurement. So like 4.700 meter means last 20 basically denote that the accuracy of this measurement. Like we can measure up to 3 decimal point with accuracy. So now suppose the unit number is changed, right? For example, you have 4.700 meter. Now you convert it into centimeter. Okay, then you have 470.0 centimeter. If you convert it into millimeter, then you have 4700 millimeter. So since the last number has trailing zeros in a number with no decimal point, so you see this number, there is no zero after the decimal point. So it can be concluded erroneously that the number has 2 significant values, while in fact it has 4 significant figures. So basically you can understand that this is very much confusing. So this you have to understand properly. So to overcome such ambiguity, see when you convert the unit, so 4.7 is a mean meter, but if you convert it into centimeter, you will have one zero after the decimal. But if you convert it into millimeter, then there is no zeros right after the decimal. So again it will be confusing. So to overcome all these things, basically what we introduce is this 10 to the power raised b, we do it. So this is not 10b, it is 10 to the power raised b. Okay, so in that for fashion, if you denote the number, then the error will be reduced. So for example, you have 4.7 meters, the same example I have considered. Now if you want to convert it into a centimeter, then let's keep it 4.700. This is the precision of our instrument, right? But for the conversion of unit, meter to centimeter, we can multiply it with 10 squares. It is not 102, it will be 10 to 2 raised to, here it is square. Similarly, if you want to convert this value into millimeter, then 4.7, see, this number is same now, 4.700. This is our original significant number, and this is the unit conversion what we are doing. So here if you see, the significant number is changing, right? From each, when you make the conversion, sometimes the zeros will be after decimal, sometimes 1 zero, here 2 zeros after decimal, here no zero after decimal. So it is confusing, significant number computation and all. But here if you see in this notation, it is very easy to every time this accuracy value is same, right? 4.700. Whereas the if you want to change the unit, the letter per 10 raise is actually changing. So each number in this case has basically 4 significant number, right? So this number also has 4 significant, this is also a 4 significant figure, this is also a 4 significant figure. Thus the choice of changing different unit does not change the number of significant digit or the figure in a measurement. Okay, so that is the good way to represent, like in 10 raised to the power, something you can do that in that fashion, 10 to the power b in that fashion. So now next is the rounding of numbers. So rounding of numbers are very much important. Now for example, if you want to add 2, or maybe you have measured 4.768, you measured it. Okay, so but some scale you have measured maybe 4, maybe in some other measurement you made it, that is 5.28. So other measurement you made in 2-digit accuracy, whereas this measurement you made 3-digit accuracy. So in that case, what you have to do? You cannot increase this accuracy. You cannot increase, right? Because already you have taken the measurement and now you came to office. So you cannot increase the next digit here. We don't know. But what we can do is this figure we can round it off. Round it off means like 4.768, we can 3 decimal points are there, so we can make it into 2 decimal point 2, because we want to add these two value and we want to keep the accuracy, up to this point. So in that case, what will you do? We convert 3 after 3 decimal to 2 decimal. How we'll do it? This 8 is there at the end, right? So this 8 may be increased. For example, if you convert into the 2 decimal, then it will be 4.77, right? Because that it is more than 5, right? This value is more than 5 means we can raise this value. But if this value is less than 5, then we can decrease the value. For example, if it is if it is 4.763, so in that case we'll write 4.76. Okay, if this number is more than 5, then we'll increase this value, whereas if this number is less than 5, then this value will be as it is. Okay, now the next question is, if this number is 5, then what will you do? Now we understand 3 cases, right? 2 cases we understood clearly. If this last digit, if it is more than 5, then we can increase this value, and we can make it round off. But if this is less than 5, then we can keep it as it is, like 6 means 6, 7 means 7, whatever number is, it is unchanged if this number is less than 5. But if this number is 5, then what we have to do? Then basically we have to make it that this number is an even number. So for example, currently if this number is 5, last digit is 5, then we'll keep it 6, because 6 is an even number. But if we have another number that is 5.775, so in that case what will happen is last digit is 5, right? That means we have to, this number, now it is odd number, right? We have to make it even number. So in that case we'll be increasing this number. Then if you round it off, then it will come 5.78. Okay, but if you have another number 5.785, so in that case what will happen, this last digit is a 5, right? So that means this number is already even, so it will be not changing. So 0.78, it will be 0.78, 4.78, sorry. So this is the rounding off rule. So you understand, rounding off rule is very easy. So last digit, if it is more than 5, then we increase this digit into 1. If it is less than 5, then we'll keep it as it is. But if it is 5, then we'll keep near to the even number. Where you have the even number here, that will do it. So if you see, this is the example it is shown. So 4.745, right? So if you round it off into 3 significant digit, currently it is 4 significant digit, right? 4745. So we have the 4 significant digit in this number. Now we want to convert it into 3 significant digit. So in that case, what will you do? You have the last 5, right? Means, and this is already even numbered, so that means there is no change in that. So 4.76 will be the 3 significant digit. Whereas this one, see, 5 is their last, so this one is already odd, so you have to increase it, because you have to make it even number. So this will be 4.74. This also comes out to be 4.74. So that is the rounding of numbers. So that rounding of numbers, basically in that rule we will be following. So the next is rounding off and the significant figure in the arithmetic operation. So once we do the operations, because in field you will find some length, as I mentioned in the earlier slide also, some length may be 6.27 meter, some length may be 4.3 meter. So if you add it, so this has actually 3 significant number, whereas 3 significant figure, whereas this number has actually 2 significant figure. So again, it is very difficult, right, to convert. So we have to do the rounding off. So rounding off and significant figures in arithmetic operations. While you do arithmetic operation, addition, subtraction, multiplication, and division, then how it will be changing. So the arithmetic calculation involves the observed measured quantity should be such that the resulted quantity cannot be more precise than the original or observed value. For example, if you measured in 2 digit, right? You have measured. So two numbers, for example, you measure 2 distance. Maybe one is 5.76, another is 8.31. For example, 2 measurement you did. Now you want to add both the measurements. Okay. So if I give a real life example, maybe you are on a site. So you are on a site, right? So this point to this point you want to measure. What is the distance? So you have considered one more point at the middle. So you have find out what is the distance this one and what is the distance from this one. So this distance is 5.76, whereas this distance is 8.31. So now what is the total distance? Total distance, you have to add both the numbers, right? Both the numbers. So both the numbers, if you add it, so you will get some value. So this original measurement, you have considered three significant number, right? So it is precise up to 2 decimal points. So each measurement up to 0.76, right? So if you add it, the addition value also should be up to original one. This means in the this one in this final, if you do the addition value also should have 2 decimal point, not 3 decimal point. For example, it may be 14. If you add it 14.07, right? If you add it, it will be 14.07. So you should not write 14.070 something like that, because in the original figure we have the two significant, I mean the 2 decimal point, right? So in the final figure also, here also we have the 2 decimal point, it should be. So something like that. So the original, after you do the arithmetic operation, the significant number or should not be more precise than the original observation. So in original observation you have some value. So in the addition arithmetic, after you do the arithmetic perform operations, after that also the significant number should be same, or the accuracy should be same, or it may be less also depending on the situation, but it cannot be more. Because why I'm telling it may be less, because if one measurement is taken up to 5.76, whereas this measurement is taken 8.3, not 1, 8.3 up to this. So this measurement has 1 accuracy, whereas this one has 2 decimal accuracy. So the net value should be up to 1 accuracy, but it cannot be 3, 3 decimal accuracy. So that is the meaning here. So if you see, this is the example we have shown here, 6.27. If you add it plus 4.3, so if you add both, you will get 10.57, and this will be, because here one value is 1 decimal accuracy, so we have to round it off to 1 decimal. So this is 5.7, means it is more than 5. This digit is more than 5, so we have to increase this into 1, so 10.6. Similarly, here also, if you see, this has 5 significant digit, whereas this has 4 significant digit. So if you add it, so you will get final one, this one. Now you have to round it up, because this is the least count, right? Least one is this one, 4 digit, 4 digit value. So this is the round up value. So the formula, the equations or the rules, basically whatever we have discussed in earlier class, same thing we are doing here. Similarly, for the subtraction, also same values, same rule will apply, and for the multiplication and the division also similar. For example, you want to multiply this length with this length. So okay, so this will have, see how many least significant numbers are there. So here how many significant figures are there? 1 2 3 4 5. This number has 5 significant figure, whereas this number has 1 2 3 significant figure, right? So when you multiply both the numbers, the resultant value should have 3 significant figure, not more than that, because here also least is 3, right? So which one is least, that we have to consider it. So if you multiply this 2, you will get, this is a big number, right? But we have to consider 3 significant figure, because our least value is here 3 significant figure. So 3 significant figure means 31.3, or you have to make it into 4, right? 31.4, round it off to 3 significant figure, right? So like that, all the divisions, multiplications, we have to do it using our rules which we have discussed in the last slide. So in this lecture, basically what we have discussed is very important parameter, that is the measurement, because when you go to field, we'll do a lot of measurements, but we find it out distances, we find it out angles, all these things we will do it. So that's why it is very important, very much important for us to do the rounding of errors, to overcome the errors. Basically we do a rounding of the numbers. Similarly, we find it out the significant figures, all these things, and we ultimately record it accordingly. So all the rules whatever we have discussed in this lecture basically will be used for the entire serving course for the after in the future lectures as well. Okay, thank you.